Yes. I thought I'd share something with y'all. This picture, see that picture? That is on the side of a middle school. I'll show you where that is. Somebody climbed up there and put that on the side of this middle school. I mean, this is side of the middle school. You can see it up there at the top. It's kind of cool. It's nice creative spirit. That's about it. All right, y'all, this is last class. And then I'll give y'all the quiz once we go through all this. Any particular homework problem you want to make sure I go over? Because probably just do first. All right, I'm muting y'all because of the feedback. Again, some internet connections are not as strong, so when you have noise in the background, it can spike sometimes on internet connections. All right, nothing in particular. Okay, so you know, here 33, you can convert this to base 2, and then the exponent's equal. Whereas over here, logging both sides, right, and then the power becomes part of the value, so then you can do the reverse of the power property and then divide. And then here you didn't have the option of converting to base, so logging both sides. Now I skipped a step, so I usually put the exponent right in front of the log instead of having a second step. Maybe you already know that. And then I decided to divide by log 3, and then we want to get the x's on the same side, so I added the 3x and then factor out the x. And then now I'm multiplying the log 3 to both sides to get rid of this denominator, so that comes here. All right, and then this in parentheses is a whole bunch of log properties, so I converted that and then divided. All right, so you want to get used to doing this because these logs are highly irrational, so you're going to have to estimate them if you convert everything to decimals. So it'd be better to estimate something that's already accurate rather than have an estimation of an estimation, especially logarithmic scales. A small difference is really big, right? The difference from 10 to the first, 10 to the second, even though you just went from 1 to 2, for instance. All right, and then here was the quadratic forms. And so as long as these exponents are doubled, then you can do that. And remember, if it equals a negative, that's never possible because you can't raise a positive number to an exponent and get a negative. So this is the only one that was possible coming from that second factor. 53, you had to convert the 16. And then once you did that, then you had your 2x and x. And here you had to convert because if you add the exponents, you had to originally have multiplied the bases, right? So that means this 4 is the coefficient of the 4 to the x term. So A1, B4, C negative 3. You can do the same thing as 49. And then same reason. Not possible because you can't raise a positive number to an exponent and get a negative. Okay? And then now 57 had no solution, and you could have seen that 2 ways. I'll point out the second way in a moment. But if you went ahead and got these to be the same base, then you would want to use 2 squared here for 4. Okay, and now you got your quadratic form, right? So there's the ABC. It's not factorable. Okay, so then using the quadratic formula, 2 to the x, we wind up with a square root of a negative. So no solution. Now, if you looked at the original problem, these are all positive numbers, right? You're never going to get a negative when you apply an exponent to a positive 2. So how are you going to get 0 if they're all positive? The only way that can happen is if they're all zeros, but that's 8. So that's a little less mathematical. 53. That was it okay when I went over 53, Connor? I just looked up. Okay, cool. All right, and then in the down here you want to divide first. If you can log both sides now if you want. It's just I think a little easier if you divide first. And now you log both sides. And again, notice I'm automatically doing the power property, right? And then if you got a number multiplied to the log after you divide by 3 log 2, you might as well make that the exponent to the value. That way this is a little more concise. And if 43 was a little involved, you're still logging both sides, right? You still want to get the x's on the same side. So I decided to divide by log 7 here. And then I added the x, then factoring out the x. Okay, so that's going to equal 1. So I multiplied both sides by log 7 to get rid of the denominator. So that's how this happens. And then I did a couple steps here. Notice that this, in parentheses, you can do some log properties, right? So that's why it's 7 times 3/5. And so then you get that. Okay, and then this 47 was an interesting one because pi and e, Euler's number, both of these are transcendental numbers. And that means that they're numbers that come about through some infinite process, right? That's what that means. So they also go on forever, have no pattern. So since the base is e, you might as well use ln. So you could have used log if you wanted, no big deal. But that way, when we ln both sides and we get to this right side, this is 1. So we don't have to worry about one of the logarithms because this can simplify to be 1. Again, I wrote this over here in case that's an issue. So remember, if you log the value using the same base, you need an exponent of 1, right? So you log the 2 and it's base 2, you need an exponent of 1. All right, so then now we can go ahead and finish this part right here. Getting the x on the same side and then dividing after you factor out the x. Okay, and then 51, notice when you simplify this middle term, if you add the exponents, it's because you multiplied like common bases. And so the 3 becomes the b term of the quadratic form. And again, the same thing, once you factor it, right, then you can't equal a negative because there's no number to a positive base that will cause a negative. Okay, and then same thing here, turn that into 5 squared, and then the same thing. Now this one was a little tricky, 59, because you had to realize how to transform this to a quadratic form. And right now it's not, because notice the exponents aren't doubled. But if you notice, if you multiply 4x to the x times 4 to the x, that'll get you a 4 to the 2x. And if you multiply a 4 to the x times a 4 to the negative x, this will wind up with an exponent of 0. So if you multiply 4 to the x, everything here, you wind up with the quadratic form. And so then rearranging to get the trinomial in the correct order, and then we can do the problem as before. The only solution comes from this left factor. Okay, y'all, anybody need anything? Okay, well, ooh, y'all don't need to see that. That's the stock market. It's all green. That means the stocks are going up. Yay. It's been nice having y'all. It's been a good year. Odd way to end it, but you know, it is what it is. As far as August, when we come back, I really don't know. I don't know how it's going to go. I know something will happen, you know, but I knew I'd say, but I don't. Things are changing rapidly. Okay. So let me make sure I got everybody, and then I'll send you all the quizzes. So I got Catherine, Connor, Dimitri, Joe, Kenneth, Luca, Patrick, Peyton, and Pierce. That does appear to be everybody. Okay, does anybody need anything? You're welcome. You're welcome. My pleasure. We made it. We did it. Love you too, Patrick. You're welcome, Catherine.
See you, Mr. Napoli.
All right, y'all.
Thank you, Mr. Napoli.
Welcome. You're welcome. You're very welcome.
Thanks for a good year.
No problem at all. No problem at all. All right, shoot me a message if you need anything. All right, y'all take care.